Welcome to Monochemistry. Today we're going to look at energy level diagrams. The first thing we need to do before we can actually do an energy level diagram is we need to look at the periodic table and refresh our memory as to what valence electrons are. So just refresh your memory. A valence electron is an electron that's in the outermost energy level of an atom. Okay? And those are the electrons that are going to be able to be used for ionic or covalent bonds. How do you tell how many valence electrons are actually in an element? Look at the group number. This is group 1. Group 1 tells us a lot of things, but it also tells us that each of these elements has one valence electron. Group 2, each of them has 2 valence electrons. We're going to skip these guys for now. We'll get to those later. Group 13, drop the 1, and it tells us that each of these has 3 valence electrons. 14, same thing, drop the 1, each of those has 4. Group 15, 5, group 16, 6, group 17, 7, and group 18, with the exception of helium, have 8. Helium only has 2 electrons to begin with, and therefore can't possibly have 8. Okay, so that's how you determine the number of valence electrons. In terms of energy level diagrams, we're going to have to be able to do them for the first 20 elements of the periodic table. Okay, so we're going to pick a couple in a second here, and we're going to do the energy level diagrams for a couple of these. And then maybe you can try a couple on your own to see if you can do it. And you can bring those to class to show me that you can do them. Okay, so I'm going to pick 2, let's say carbon and magnesium. And then you can pick 2 other ones. Okay, so we're actually going to draw our energy level diagrams now. Step 1 to drawing an energy level diagram is to write down the element symbol. Okay, so I said I was going to do carbon and magnesium. So I'm going to start by writing carbon, the symbol for carbon. Okay, now carbon, as you recall, has 6 electrons. So how many energy levels is that going to be? Well, recall that the first energy level number 1, can hold 2 electrons. And since carbon has 6, it's going to fill that. So we'll put a 2 there. Okay, so that's the first energy level. Okay, the second energy level can hold 8 electrons. So carbon, having 6 electrons in total, we've already used 2, has 4 electrons left. Okay, so take a look at this. The step 1 was to write the symbol, which we did, C. Step 2 was to determine the number of valence electrons, or the total number of electrons, pardon me. Well, carbon has 6. The third step is to determine how many energy levels carbon has. Now there is a shortcut to that, which I'll get to in a little bit. But right now, you have to remember that in the first energy level, there's 2, can hold 2 up to 2 electrons. The second energy level can hold 8, up to 8. The third can also hold up to 8. Okay? So there's carbon, and once you've determined the symbol and the number of electrons, you simply put the number of electrons in each of the levels. So we're going to do magnesium next. And magnesium is element number 12, and therefore has 12 electrons. Okay, so we'll do the same thing. How many electrons can fit in the first energy level? Well, the answer is 2, so I'm going to go ahead and put 2 there. Okay, how many electrons can fit in the second energy level? Well, the answer is 8. We had 12 to start with, minus 2 is 10, so we still have 8 left, so I'm going to go ahead and fill that up as well. There's 8, which means there has to be a third energy level. 8 plus 2 is 10, so there's 2 left. So magnesium is going to have 2 electrons in its outer energy level. Now, what's the purpose of an energy level diagram? Well, it does a couple of things. First of all, it shows you how many electrons are in each energy level, which is important, but more importantly, it shows you, quite simply, how far away each energy level is and the correct number of valence electrons. 4 for carbon, which if you look is correct because carbon's in group number 14, and 2 for magnesium, which is also correct because magnesium is in group 2. Okay, so you pick any two, try them, and bring them to class. Make sure you get the hang of this. If you have any questions, make sure you write them down. That in a nutshell is how you do energy level diagrams.